Hello everyone. Thanks for the welcome there. Thank you, Agnes. So my name's Tom Koerner. I'm Operations Director with Thompsons of Prudhoe. This is the first time that I've presented at the World Demolition Summit, so please go easy. I attended last year's summit as a delegate with our Managing Director, Nick Schilling, and we had such a great time that we thought we'd come back this year and brought the rest of the board with us. Okay, so I'm going to talk about a project today which has been a key milestone in both the industrial heritage of the northeast of England and also within the evolution of Thompsons within our business. So very briefly, and hopefully to add a bit of context to what I'm going to talk about, here's a quick introduction to Thompsons, so you can gauge the size of the company that we are. We were number 37 in last year's Demolition and Recycling International Global Contractors Top 100. We're currently turning over in the region of £90 million. Obviously conscious we have an international audience here, so I've included up there Canadian dollars and US dollars on the slide here, but for the purposes of the rest of the presentation, I'll just refer to US dollars for ease. So Thompsons are a family-owned organisation, and have been from the very beginning. Our business owners are all third generation members of the family, two of whom are here today, our chairman John Thompson and also our group director Helen Hillary. I'm not part of the Thompsons family myself, but I've been working for the business for over 9 years now. Prior to working with Thompsons, I worked in construction management for a number of years, until I decided to do something much more exciting and started knocking things down instead of building them. So our head office in the picture here, that's based in Prudhoe, which is near Newcastle in the northeast of England, and our business has now been established for 75 years, where we're now taking on bigger, better and more challenging projects than ever before. That's on both a domestic and an international level. So again, very briefly, just on this slide, it's just to quickly give everybody a snapshot of what we do. All aspects of our business at some point meet with each other throughout the life cycle of our projects. So it's nice that we can regularly rely on another facet of our company to help another part of the company out. So to summarise, really, we're a turnkey contractor and providing a sort of a one-stop shop solution to our customers. So, on to what I came here to talk about. This was the former Redcar Steelworks in the northeast of England. That's only an hour from our head office to drive. It's the kind of project that if it was 10 hours away from our head office, we'd still drive it because it was that much of a good project for us. We were just very fortunate it was sort of almost on our doorstep. The steelworks was central to Teesside's long and rich industrial steelmaking heritage. The site had a worldwide reputation for its products spanning around 170 years. Many of the world's most iconic buildings and structures were built with the steel that was made at this plant. That includes the Sydney Harbour Bridge, it includes London's Shard, and various other sort of iconic structures around the globe. So this steel industry within Teesside played a defining role in the lives of hundreds, if not thousands of people in the Tees Valley across multiple generations. Many of the structures on the 18-kilometre squared site were iconic, again, to the skyline across the region for decades. However, unfortunately, in 2015, the site was suddenly closed, which came as quite a shock to the region. Employees were literally at work one day and then told not to come back the next. The closure ripped the heart out of the local communities with 2,000 jobs lost. So, as well as the direct disastrous impact upon so many people, the fact that the site was closed so abruptly meant that it wasn't planned. And unfortunately, as steelworks don't just have an off button, this caused a number of problems, which I'll touch upon later throughout the presentation. So within 2 years of the closure, there was some positive news finally about the site, where an announcement was made about a UK government-backed 25-year vision to build a world-class industrial facility focused on clean energy and advanced manufacturing with a view to create thousands of local jobs. Further to that, the then UK Prime Minister Theresa May launched South Tees Development Corporation, which was subsequently rebranded to the more snappy title of Teesworks, which I'll refer to a lot throughout the presentation. Teesworks are effectively the client. So to give an indication of as to how important the site is to the UK government, all UK Prime Ministers since Theresa May have visited site. And for those of you who follow UK politics, that is quite a few. In order to do all of this development and build these nice shiny new facilities, which they've now started doing, they first needed to decontaminate and demolish what was there already. And as you might have guessed, that's where we started to get involved. So, in terms of our appointment onto the framework, we opted to tender for the Lot 1 framework for demolition, which was for the larger items of plant on site. We, amongst a handful of other large UK demolition contractors, were then delighted to be appointed onto the framework. We started working on the Teesworks site in early 2021. We won the first tender on the demolition framework, which was for the decontamination and the demolition of the stockhouses plant, which to us was a $2.4 million project. We then won a number of other contracts, which I've listed on the screen here. Under our contract, the total value of those contracts has then transpired to be somewhere in the region of $110 million. Under our contract with Teesworks, I was appointed as the nominated framework director for Thompsons. So the challenges that we went on to encounter, a lot of them became sort of my headaches to deal with, if you like. So I thought for the purpose of this presentation, I would focus on sort of three specific headaches that we had, that we encountered throughout three separate contracts throughout the site that we were working on there. The first project that I'm going to discuss is the Boss plant. I'm then going to talk about the South Bank coke oven battery project, and then finally the Redcar blast furnace. So first of all, I'm going to talk about the basic oxygen steelmaking plant, or what is known by everybody on site as the Boss plant. So the contract value was just below $30 million, and it's certainly safe to say that was proportional to the physical size of the structures and the site in general. It really was a vast site. I have some shots in a video shortly where you get a better scale of what the project looked like. The photo that I've got on the screen there is part of the cathedral section, which was sort of the last bit that we came to. So the site itself was 378,000 meters squared area. The structures themselves were up to 520 meters in length and up to 70 meters in height. That was the cathedral section there, which was the tallest part of the site. The project took just under 2 years to complete. So moving on to the first challenge that we encountered, or the biggest challenge that we certainly encountered on the Boss plant. It was working from height. Within the Boss plant, there was what was sort of locally known, as I said, as the cathedral section there, which was 130 meters long, 70 meters wide, and 70 meters high. We determined from the outset that the safest and most efficient demolition methodology for this part of the plant was to carry out a controlled explosives blowdown, which would take place in the later stages of the project once we've cleared the surrounding areas of plant and structures. The explosive engineering subcontractor that we were working with initially proposed an excellent technical blowdown solution for us, which we were very satisfied with the design of which, from a technical perspective. However, from a practical perspective, from a safety point of view, it would have resulted in prolonged manual preparation and pre-weakening work at heights for Thompson's operatives, where they would be working somewhere in the region of 60 metres up in the structure. Not only that, but in order for our guys to get there, they would have had to have worked from scaffolding platforms, so therefore not only do we need to send our guys up there, we need to send scaffolders up there as well for really significantly prolonged periods of time, where we've also got the additional risk of manual handling as well as working from height. So to try and put it simply, the safety risks were too significant for the initial proposal to be viable for us. So here's what we did. To try and overcome the challenge that we had there, we applied the first rule of working from height, which is don't work from height. As the principal designer and the principal contractor under UK CDM regulations, we engaged with our subcontractor, that's SES, and their designer, who was working for them, Richter Associates, to try to design out any significant working from height, using shared technical competencies across all parties. The team evaluated and determined the safest and most effective, efficient design to bring the structure down. With the support from Thompson's in-house structural engineer, our temporary works coordinator, our demolition engineers, and the health and safety team, the project team were able to significantly reduce the risk of working at height, down from 60 metres to around the 30-metre level. And that was with a large reduction in execution time too. And that 30-metre level where our guys were working was from an existing working platform, from an existing concrete slab, where the risk of a fall from height was significantly reduced anyway. And not only that, that reduced the requirement for scaffolding too. As you can hopefully see on the design at the top right there, that was the design that we went with, where there's some very, very minimal works that we had to carry out at the 60-metre level, which was literally perhaps a day's worth of work, as opposed to weeks and weeks for tens of men. So here we can see the before, the during, and the after. At the top right, you can see our engineer Rob Clark's collapse mode when he was working for Richter Associates. So he predicted what was going to happen. I don't know if you can see that there, but the different periods of the collapse there are at 3, 5, 7, and 10 seconds. And even though the cathedral section came down in those seconds, it took months and months of planning from our in-house team and subcontractor experts to make it work. And as I'm sure you can imagine, we were extremely happy to see it come down just like we said it would. So I'll put a video on now. So I'll just talk through it to hopefully give a wider picture of the job. Here we can see the scrap brace structures, the winch pits, engineering workshops, control rooms, the welfare offices, the overhead travelling cranes, the mould bay, the cool bay, the teaming bay. There's chimney stacks there. Also underneath the structure, we've got cable tunnels and water treatment works. So a sizable project. As I mentioned before, the works were delivered primarily by Thompson's in-house. However, we did also use some trusted subcontractors throughout the project to assist our operations. Decontamination was carried out by WSG, and the blowdown engineering was expertly provided by Ian Beasley of SES, with Richter Associates as their designers, led by Rob Clark. All other activities, it led in-house by Thompson's. Throughout the project, we applied a number of different techniques, including mechanical demolition, push-downs, pull-downs, hand demolition, pre-weakening, crane lifting operations, and the aforementioned hazardous material removal. We had our full house in-house structural engineering services in place, who were carrying out surveys, calculations, analysis, and we had an external temporary works Cat 3 supporting checks carried out too. The explosive specification that we used included 150 shape cutting charges, 3,800 metres of charge line, 1,700 kilos of gelignite charges, and around 1,600 detonators. So because of all these big numbers, the Boss Plant Cathedral section became the UK's largest controlled explosion in the last 75 years. We estimated that around 105,000 tonnes of steel was brought down within this one blast that you can hopefully see now. It's safe to say there were a few hearts and mouths during the blowdown, especially when we were waiting for the dust to settle so we could get an understanding of what we were left with, and most importantly, what kind of height was left in the scrap pile. But as I say, thankfully, it came down like we thought it was going to. Okay, so moving on to the challenge number 2 that I'm going to talk about. This was at the South Bank Coke Oven project, so not too far away from the Boss plant. The South Bank Coke Oven covered an area of around 62,000 metres squared, and the overall project value came in at $23 million. As I touched on earlier, the operations at the steelworks were halted abruptly. That led to a scenario where there wasn't adequate time for a shutdown back in 2015. This resulted in the majority of the coke oven gas systems, tanks, vessels, contents and substances all still being present. The coke oven gas main pipelines traversed across the project site area. The pipeline was mounted on a steel frame on pipe gantries and pipe bridges, and the pipe was known to have pyrophoric material present. Pyrophoric material meaning that it sets on fire during normal atmospheric conditions and where there's no spark needed. So it's, understandably pretty nasty stuff. There was a redundant coal bunker, which is at the sort of the further end of the shop there, in the southwest corner of the project site, and that had an estimated 400 tonnes of coal remaining inside, which was hung on the internal surfaces, which was a significant challenge as well. The only way to viably bring the majority of the structures down was via explosive blowdown. We did what we could mechanically beforehand, but the significant majority of the site had to come down via explosive blowdown again. And all of the above was further complicated by a significant amount of asbestos insulation that we had to remove from the pipelines, which were in the collapse area of the proposed blowdown. Like I did with the Boss plant, I'll talk through some more detailed information about the project in general when I show a video in a few moments. But I'll get to the the second key challenge, I should say, rather, that we were up against, which in this instance was politics. It was the politics surrounding this particular contract. The Teesworks projects in general were pretty political, but this one really was sort of extra special in that respect. So for this contract, there were a lot of key stakeholders that included the client, subcontractors, neighbouring contractors, the police, the fire service, paramedics, our UK health and safety governance, the health and safety executive, Network Rail, so they operate the railway directly next to site, which is a busy local railway. English Heritage were involved, the local planners, the Environment Agency, statutory service providers, the media, external security companies, and then, of course, there was the Mayor's Office, the local authority, and members of Parliament all got involved as well. And we were there as the principal contractor and the principal designer, trying to make things happen still. So the blowdown had to go ahead on the 19th of September, because that was the only date that we were going to be given permission by Network Rail, who operate that busy railway that I mentioned a few metres from site. And their railway was within the exclusion zone, so we had to take possession of it. The reason that we had to take it on the 19th of September was because they already had planned maintenance for that night. The railway was going to be closed, and it was essential that it was carried out then. If it wasn't carried out then, there would be a period of a wait of around 10 months until we could do it again, which simply wouldn't be viable for the client due to funding reasons. So after carrying out several months of decontamination, demolition and preparation works, leading to this explosive blowdown on the concrete bunkers, which was intensive and challenging enough for us, it was then requested by the client at a very late stage to include this, which is the Dorman Long Tower, as part of the demolition scope. The Dorman Long Tower was built in 1955. It was built as a coking plant for steel production. The tower was a very early example of brutalist architecture, and it was therefore looked upon with, despite its appearance, with quite a lot of fondness from a lot of local people. The client's brief when they told us that they wanted this to come down was not only that it needed to be demolished within our scope, they also needed to include it within the blowdown set date of the 19th of September. If we couldn't fulfil their request, we were made aware that it could potentially put the whole project into jeopardy, which is certainly not what any of us wanted. Because we wanted to continue to delight the client and subsequently hopefully win more work elsewhere on site, we got our heads together with Robin Rushforth of PDC, who was our explosive engineer on this particular project, and we came up with a plan as to how we could prepare the structure and how we could get it charged up in basically record timing. Public sensitivity surrounding the tower, as I touched on before, was certainly very prominent, and all of the local news and media outlets were taking a very keen interest in the building's status. Word inevitably got out fairly quickly that the client was wanting to demolish this structure as part of the wider South Bank Coke Oven project that we were delivering. Almost immediately there was then a campaign started to save the structure. Despite the fact that the structure wasn't structurally safe to maintain, I think that perhaps wasn't communicated to the general public so well, and therefore, as far as they were concerned, they were losing a vital piece of the history. So the pressure then, because of this campaign, then increased for a number of days until, with less than a week to go until blowdown, an emergency application was submitted to Historic England. They then granted the Dorman Long Tower Grade 2 listed status. So Grade 2 listed status in the UK effectively means you really can't do anything to it at all, certainly not knock it down. So that section of the project with immediate effect was then immediately put on hold. We had to wait whilst the government discussions took place to determine the building's future. Within this period of time, the Dorman Long Tower was really used as a bit of a political football. It was being kicked between various different political entities, including Parliament, who was split on the decision as to what should happen to it, really depending upon which political party they represented. So safe to say, it was quite a stressful time for everybody. So trying to overcome the challenge, within a period of time, with the period of time that I mentioned there, we had to wait patiently for a decision to be made. There wasn't really much that we could do other than get on with our jobs and prepare the rest of the site for blowdown, whether or not the Dorman Long Tower was going to be included in it. We had to therefore make a plan for two options: if the Dorman Long is included or if the Dorman Long isn't, which again, a significant amount of management time and engineering had to go into making two decisions, one of which we knew wasn't going to go ahead. So after a number of days of this being headline news in the region, it took a cabinet shuffle from the then Prime Minister, Boris Johnson, who appointed a new culture secretary in his cabinet, and then literally within the first hour of the new culture secretary being in her post, she controversially revoked the Grade 2 listed status of the structure, allowing us to progress with the works. So at which point the allotted slot for demolition was less than 48 hours away, which was somewhat of a concern for all of us. So we worked collaboratively with all internal and external stakeholders. We exhausted all of our required resources. We had to bring guys in from not just elsewhere on our steelworks projects, but literally from the Thompsons in its entirety, to work all hours, 24/7, evenings and weekends, to aggressively deliver the required preparation works ahead of this 2 a.m. deadline, where we were given by Network Rail to complete the works. So here, understandably, collaboration was absolutely essential, as we effectively had to complete over a week's worth of work within 2 days. And of course, almost goes without saying, but obviously we had to do it safely as well. So we held sim-op meetings with the clients representatives and the adjacent working parties, to ensure that the key milestones were being collaboratively achieved in the hours leading up to the blowdown. So I'll just again put another video on again, so hopefully you can get a bit of a better feel for what kind of the site was like beforehand. So the project comprised of everything that you could just see on the screen there. That includes the quench towers, the battery bunker, there's a chimney there, the welfare block, the coke oven gas main, which I touched upon before, a gas collector main, there were some bleeder stacks, coke pushers, a conveyor system, 3 substations just there, one of them was live, pipe bridges, and we also had a significant earthworks and ground remediation project which was ongoing that we're carrying out as principal contractor. That's still going on today, all of this time later, as part of a phased completion. So there goes the blowdown. So the South Bank coke oven battery consisted of 88 ovens split into 2 batteries, east and west, and of 44 oven chambers each. The oven chambers were 5 metres in height, and the South Bank coke oven battery was used for the carbonisation of coal within 24 hours by heat transfer to the heat oven chamber, refractory walls into the coal, and the non-coke products were transferred by pipework to the gas cleaning and byproducts recovery plant, which was located just off-site. As I mentioned before, we were appointed to undertake the full decontamination, engineered dismantling, the waste disposal of all the structures that I mentioned, whilst protecting any retained assets and utilities within the site boundary. Okay, moving on now to the third project that I'm going to talk about today, which is the Redcar blast furnace. The Redcar blast furnace was commissioned in 1979, and at its peak it produced up to 10,000 tonnes of iron per day. The blast furnace was on a site, a wider site that was part of our contract CDM area of 147,000 square metres in area. Like the rest of the wider steelworks site, again this shut down for the final time in 2015. On this particular project, this is where really almost no decontamination being carried out at all prior to our involvement. Therefore, that was included within our package of works. This particular project was certainly at the forefront of the public's attention again. This is due to the 100-metre high structures being visible for miles along the northeast coastline, with the local, national and international media outlets showing a keen interest as the project progressed. There wasn't a public campaign as such to save the structure in this instance, because I think everybody accepted the fate of the fact that it didn't work anymore and couldn't be used. But there was still, understandably, a lot of emotion attached to the fact that it was going to be demolished, which we, as the main contractor, had to do our best to deal with sensitively. So the key challenge that we encountered on this project that I'd like to talk about is a technical one. We needed to carry out a significant decontamination works exercise, which included the safe removal and the disposal of residual coke oven gas. As I mentioned earlier, that's a pyrophoric material. The pyrophoric material, therefore, is setting a light to itself if it comes in contact with normal atmosphere. That's manageable by putting it under a nitrogen blanket when you know that it's there. Unfortunately, in this instance, because there was such a poor amount of as-built information, we didn't know where it was, so we had to carry out our own investigations to determine that. So we progressed with this significant amount of the demolition around the RBF site, which you'll be able to see in a moment on the screen when I show the next video. And we began the highly technical process of trying to understand how to bring this incredibly heavy structure down. The task was therefore made a lot harder because, as I mentioned, we didn't really have any historic as-built information, or the as-built information that we did have was pretty sparse, which again, that was a result of the way in which the site stopped. It wasn't progressively shut down, they just walked out one day and didn't come back. So further challenges in the form of limited access to the structure that you can see in the photo there, to the furnace itself, and limiting loading capacities. There was therefore a limited size of machinery that we could use there, and that affected the decision-making process on how to safely fell such a heavy structure. we conducted a structural survey of the cast house floor, so that's what that cherry picker is just sitting on there. Unfortunately, it wasn't great news when we carried out the survey, and the structural survey effectively told us that the largest piece of machinery that we could track on there was a 13-ton machine. We would have much preferred to get something quite considerably bigger on there, but we simply couldn't do it. The cast house floor was at a height of 12 metres, so we just had to work with what we had. The age, the complexity, and the limited retained information on the scale of the blast furnace therefore provided us with extensive engineering challenges. We needed to carry out a blowdown and achieve rotation of the blast furnace whilst maintaining the structural integrity right until that last second. So here's how we did it. First of all, we had to conduct reverse engineering and conduct intrusive structural investigations. So by working from engineering first principles, we were able to understand load distribution, support characteristics, and how the structure retained its stability before producing a detailed plan for its removal. To achieve the blast furnace rotation, a significant amount of material was removed from the blast furnace. Up to 2/3 of its circumference had to come out, and 4 metres in height. The wall thicknesses there were around 70 millimetres thick, with internal layers of steel cooling staves up to 120 millimetres thick. Carbon blocks and refractory block material were also present, and they needed to be removed as well by limited means of labour-intensive burning and mechanical works. But using that small plant that I mentioned had to be 13-ton excavators or below, and then we also had to use low-weight material dumper trucks. So again, this is added to the time that we're spending, to the safety risk that we're encountering as well on the project. So as the large opening in the blast furnace was required to rotate during the explosive event, this meant that the material removed had to be replaced with fabricated 6-prop temporary support design that could be removed by explosives, and that's what you can see. We're getting the first one in there. This prop was a key engineering feature that contributed towards the project being a pretty unique piece of demolition engineering. Each prop had to be installed at set locations. We had to use a set sequence, and not only that, get the angle exactly correct, so it's aligned with the blast furnace shell to ensure that we retained the structural integrity and stability, because obviously you've seen the size of the structure that was on top of it, which was really quite significant. So I think really it's safe to say these props were the piece that made the project quite a unique piece of demolition engineering, as they literally underpinned the key to a very successful blowdown for us, thankfully. So again, I'll put this video on here and I'll do a little bit of a talk about what happened in it. So as I mentioned earlier, the legacy of the facility of the blast furnace structure presented us with vast challenges when we prepared the structure for demolition. During the operation, the iron-making process required the coke oven gas that I mentioned, and therefore had residual coke oven gas, which was a major concern to us. We understand that this is the first blast furnace that we've taken down, but from our research, we understand that conventionally blast furnaces are demolished by blasting at a low level. However, this simply wasn't practical in this instance due to the blast furnace unique design of the structure and the way that the furnace was shut down following the site closure. So following months of detail engineering works by Thompsons and our subcontract partner PDC, working in collaboration with our in-house demolition and structural engineers, we created this novel design that I mentioned, which allowed for the blast to take place from the casting house floor. And there it goes. So with the blast live on local, national and international news channels beaming the event around the world, we safely and successfully carried out the non-conventional blowdown using these new design techniques in collaboration with our subcontractor Robin Rushworth of PDC. what is probably worth mentioning as well is prior to starting the pre-weakening design, we continually monitored the structural conditions and measured any structure movement during the works. This is particularly important on this particular blowdown due to the propping system that we're putting in, taking away that 2/3 of the circumference of the furnace, which was holding the rest of the structure up. So a team of our surveyors frequently attended site, and they used lasers to measure any sign of movements as the works progressed. This here's a separate blowdown for the stoves, which was carried out. We carried this out a number of months later as blowdown number 2 at the blast furnace, after quite a significant amount of preparatory work as well there. So the UK regulator that I touched upon before, the Health and Safety Executive, the local authorities, the police, emergency services, and several site stakeholders were involved in the preparation and planning works for the project. We held periodic meetings with all parties throughout the planning, detailed design, pre-weakening, and execution phases of the works. The project was classified as a major event by the local authorities, with engagement from all parties at the highest level of their respective organisations. We ensured that a suite of comparative risk assessments were carried out by our in-house demolition engineers and structural engineers, determining that explosive blowdown of the site would be the optimum demolition methodology for these works. So, in conclusion, we have on the Teesworks site, throughout all of the projects that we've carried out there, we've recovered somewhere in the region of 400,000 tonnes of scrap at a total combined value of $110 million. There isn't much of the site left now. We're still there finishing off and helping the client with the, dare I say, the trickier parts of decontamination, demolition and scrap handling, whilst the new facilities are sort of rapidly being built adjacent to us. I would say in terms of lessons learned, we've learned a lot of lessons from carrying out these contracts, and to significant betterment to ourselves, and we hope to the industry as well. I think in terms of professional learning from me personally, I mentioned before the first rule of working from height being don't work from height. In respect to the South Bank Co-Govern, I can say I've learned another vital lesson there, which is the first rule of working with politicians. Sorry, I know we've got one in, which is don't work with politicians. I'm joking, of course. Okay, so that's it from me. Thank you everybody for your time. Just going to say one other thing there, if I could just go back on the slide, there's a QR code up there in case anybody's interested to see any more videos. Please feel free to scan the QR code and that'll take you to our YouTube channel. Thank you.
Thank you very much, Tom. Unfortunately, we do not have time for questions, so please reach out to Tom during the lunch break for any questions from the audience. Once again, thank you very much, Tom.
Thank you.